Hi, everybody. Welcome back once again. I am live, and it's great to be alive. So, once again, my name is Ron, VA3FUC. I run VA3FUC, this channel, which is as I'm on. And right now, I am getting ready to redo my test. The reason for that is I want my HF privileges. HF allows me to go into the higher bands. This includes 6 all the way up to 160. I think it's all the bands that were available right now. And I could do 6-meter UHF, VHF, but it doesn't really get out that far as much as, say, the 300 megahertz band, and then higher up I can go. So that includes 6 meters, 10 meters, 12 meters, 20 meters. Really, the main activity you'll hear is mostly in 15. I've heard is popular, but it's not there yet. 20, 40, that's where most of the activity is in. 20 is really good if you want to do if you want to get around the world in cases. But a lot of people usually just stick with 20 and 40 meters. But those are the 2 most popular bands, I find, other than like UHF, VHF. There's also like something like 6 meters, which is considered the gold standard of nets that you can go on when it's you just got to be there at the right time. Here's like the most fabulous time to be on is when 6 meters opens up. It's just phenomenal. But anyways, that's not what we're here for, to discuss bands or what bands you may be on. If you have a call sign, we'd be happy to just pop it in the chat. Stick around. We're going to be answering 100 questions I got to go through. It's not the most easiest exam in the world, but if I want to be able to use, other than just being on HF, I mean UHF, VHF, this is also DMR. But I want to see what else is out there. I want to get on those 20-meter bands, 40-meter bands. Any band that I can get on would be great. The test, I have to score 80% or better. So we're going to do this test, and we're going to see where I'm good, where I'm weak. Last time I did the test, I rated it in at 63, I think it was, on my other test. Last test before that was 60, so I'm getting up there again. I'm starting to remember these questions and the answers to them. And a lot of it is on the electrical end. It's where I know I'm weak in. Everything else I'm going to be okay. So let's get into this and let's get studying. So for the Canadian exam, it's a little bit different from the North American exam. Let me pull it up here this way. There we go. So the Canadian amateur exam even has their basic practice exams. Now, with the basic practice exams, they're almost identical to the questions actually, they are identical to the questions you're going to see. There's about 5,000 questions that they pull from the bank. I have the full printout of all the questions, so I can always go into it and update it, circleize it, remember it in the head, so that when I go write this test, I'm ready for it. Anyways, here's the first one. Which type of stations transmit one-way communication? Would that be repeater station, VHF station, HF station, or beacon station? Well, I know the answer, but let's discuss this here. So repeater would just repeat your signal. So that is definitely not one. A VHF station would communicate to a repeater and can also receive. So technically, if it was in simplex, which is broadcasting on the same band, receiving on the same band, that does not qualify. HF station just means high frequency. Well, high frequency, you can send and receive. Not the answer. So a beacon station only sends out a message. It can't communicate back and forth. So all it does is just transmits a signal. It can be also, or just a sound. There is no definition for it, so it's a beacon station would be the correct answer. So we go D, beacon station. And D is correct. Now, a lot of this you'll see does relate to also the U.S. exams too. So if you're in the U.S. and you're going to be writing your exam, congratulations. I look forward to hearing what you guys got in. Just saying. So here's another question for the practice exam. How should you answer a routine Morse code CQ call? Send your call sign followed by your name, station, location, and signal report. Send the other station call sign once, followed by DE, followed by your call sign 4 times. Send the other station's call sign twice, followed by DE, followed by your call sign, or send your call sign 4 times. So when Morse code, there is something you will tweet, you'll send it out your code, then you send out your code. I know that much. So we can scratch out A and we can scratch out D. Those two are not right. The question is, how many times do you send it out? Now, if I remember, it's you send it out their call sign twice so they can hear you, then DE, and then 2 times your call sign, if I remember correctly. And so we'll say C. And C is correct. DE is just acknowledgement. Here's my call sign. Now, that's interesting because a lot of the exams no longer do Morse code. There is a Morse code exam you can take. It is not required to get your HF, though, in Canada. In the US, I'm not 100% sure. If someone's in the US can answer that, I'd be very appreciative of that. Now we come into mathematics where I suck at my electronics. So, well, let's see. Okay, if 2 microfarads are wired in a series, that means back to back, the total capacitance arrangement would be either 12 microfarads, 45 microfarads, 18 microfarads, or 5 microfarads. Oh boy. Okay. Well, you think it would be 50 altogether, but it's not. I know that for a fact. I can't remember if it's 18 or 45. 5 microfarads is too low. 12 microfarads is too low also, if I remember correctly. Either it's 18 or it's 45. I want, like, my gut is saying 45, but I'm also thinking it could be 18. Let's go with 15. Let's go with 18. Something's just screaming in my head 18, but I have a feeling it's 45. Oh, it's actually 5 microfarads. Interesting. Okay. As frequency in a signal changes, what happens to signal loss in a transmission line? This is interesting. If you know anything about SWR, heat dispersion, this is going to make a lot of sense. So, as the frequency of a signal is changed, what happens to signal loss in transmission line? A, signal loss increases with decreasing frequency. Signal loss increases with increased frequency. Signal loss is least when the signal wavelength is the same as the transmission line length. Signal loss is the same for any frequency. So this has something to do with if I remember correctly, with SWR, because length has a ability with length and everything else, because the longer you make your antenna, the less frequency you would have. So, and the SWR would build. Signal loss increase with decreasing frequency. Signal loss increases with increased frequency. Signal loss with least when the signal wave strength is same as transmission line length. Signal loss is the same for any frequency. As frequency of the signal changes, What happens to signal loss in a transmission line? Usually that's built up, causes it would come back through the radio. Signal loss wavelength is the same as transmission line length. I believe, if I remember correctly, the answer they're looking for is C. No, B. Increases with extent. Okay, increases frequency. Okay. I thought it was C, honestly. Next. 5 10 ohm resistors connected in series is equal to what? 10 ohms, 1 ohm, 5 ohms, or 50 ohms? It would be 50 ohms across, because if it was in parallel, it'd just be 10 ohms across. So let's go with 50, because that's just mathematics. Yeah. Which is not an element involving the Science Economic Development Canada public consulting process for antenna systems. Now, this is kind of one of those trick questions. There's another one where we have to consult, or they do not consult on the antenna. These are questions they throw in there that just mess with your head. So to the one person that's watching, hey, how you doing? So anyways, let's go into this. Address the relevant questions, comments, and concerns. Practice in public meetings on the project. Provide written notice. Provide opportunity for the public to respond regarding the measurements, address, and responsibilities, and the relevant concerns. If I remember correctly, that is D, which is not an element. So this is one here right now. It's not an element. No, it's B, participating in public. That's right. Like I said, trick question there. What kind of emissions would an FM transmitter produce if the microphone fails to work? Would it be a frequency modulated carrier, a phase modulated carrier, an unmodulated carrier, or an amplitude modulated carrier? Oh boy. Okay, so frequency carrier modulator, phase modulated carrier, and unmodulated carrier. Now, if I remember correctly, every carrier is modulated. It wouldn't be a phase. I know that much. An unmodulated carrier. Well, there's still going to be sound, but if it can't transmit, that's the thing. Because the microphone can't key, wouldn't there be there would be no signal going out. So that would be an unmodulated carrier, I would think. Yeah, if I get this wrong, you know what? It's only a practice exam. It lets me learn what I'm getting wrong and what I'm getting right. Yep, unmodulated. Because no transmission, then it's unmodulated. There's no signal. Because of a signal, it's like a up and down, up and down. Okay. The distance from transmitter to the nearest point where the sky wave returns to Earth is called angular radiation, maximum usable frequency, skip distance, or skip zone. Okay. Angular radiation? Nope. Maximum usability? Nope. The skip zone is if you're in that zone where the wave cannot be heard. So I guess because they're asking for distance, the distance between transmission and Earth and back to Earth. Skip zone, skip distance. Yeah. Sometimes the question will give you the answer and you just gotta catch it. Which of the common connectors have the lowest lowest loss on UHF? A BNC connector, a type N connector, a PL259 connector, a type F cable connector. I don't think it's F. I know a lot of amateur radio operators use BNC connectors on their handhelds, but most cables use a PL259. Oh, man. Now, most radios use an SMA connector for their antennas. And they use a BNC connector if they're trying to connect a different antenna that's not meant for that radio. I've never seen them use a PL259 when they're changing their antennas. I'm going to have to say a BNC connector. I could be wrong. It could be the PL259, but I think it's the BNC if I remember correctly. No, it's type N. Really? Okay. So which of the following is not exempt? Yeah, I can speak English today. Which is not the Which of the following is not exempted from the penalties under the Act of Devolence, intercepting, or information obtained through radio communications other than broadcast? A, where it is for the purpose of giving evidence in a criminal proceeding which a person is required to give evidence, where it's provided information for a journalist, where it's for the purpose of protecting properties for prevention of harm to a person, where it's on behalf of Canada, the purpose of international and national defense or security. Which is not. So keyword not. If I remember correctly, it's giving it to a journalist. Yeah, it's giving it to a journalist. This is one of those questions where it's just like, well, when do we want to give it to a journalist? No, that's where it falls into play. But you also have to ask the other question. It's like, okay, well, our radio communication is supposed to be open. We don't talk in code unless we're using Q codes, and Q codes can be easily found on the net. So, you just got to ask yourself a question. Well, does that fall under that? Just saying. You need current limiting resistor for a light emitting diode in LED. The actual resistance is not critical at all. Out of the list below, which resistor would you select? Would you select A, 0.1%, B, 20%, C, 10%, D, 5%? So the resistance is not critical. Out of which below would resistor tolerate would you select? It's not critical. I would pick 0.01 because, as they said, resistance is not critical. So I'll go with the one with the less resistance. No, they want B, 20%. That's one of those questions where it's just like, why 20? Why would you go 20 when you'd say resistant? You're currently limiting resistor for a light emitting diode LED. The actual resistance is not critical. Is not critical. Okay. Yet you don't know what power you're using. You have no idea how much power is going through. It doesn't, it's one of those odd-ended questions where you're just going, what are they asking for exactly? But anyways, what is the maximum transmitting power of an amateur station may use for SSB operation on 7.7055 kilohertz? Okay. Basic with honors. Okay, so basic with honors doesn't change the amount of amount of power we can put out. Single sideband. If the operator has basic, what's the maximum power transmission we can put out on AHF is what I think is what they're looking for. Is it 1,000 watts of PEP? No. Is it 200,000 watts of EPP? No. 550 watts of PEP? Nope. 200 watts of PE output. Now, single sideband doesn't require that much power, but if I was doing single sideband operation, I would put out the maximum I was allowed to put out, and I believe 200 is our maximum that we're allowed. Advance, I know, can put out more. I think it's 1,000 watts Advance. But if I remember correctly, it's only 200 watts. It's the answer they're looking for. But then again, it could come out with 2,000. So we'll see what happens. Oh, really? 560 watts. Okay, good to know. Next. Oh, fun. Okay. This is the one that really gets me going. So you're given a list of each radio, depending on whatever radio it is. Say it's an HF rig for transmission, an HF rig for receiving, an HF rig for FM modulation, FM rig for an AM modulation, transmitter and or receiver. So they're not all together. You got to remember where each piece of this puzzle goes together. Great. In a frequency modulated transmitter, the microphone is connected to the modulator, oscillator, speech amplifier, or power amplifier. Well, when you're talking to the microphone, you're making the microphone move, which is modulator, which I would think is modulator. But if I remember correctly, I believe it's speech amplifier, if I remember right. You wouldn't connect it to the power amplifier, you just fry yourself. But it could be wrong. Nope, speech amplifier. Okay, so UTC, Universal Time Code. Now, it could mean. Now, what answer is it though? So something you got to know about UTC. UTC is Greenwich, is also known as Greenwich time. So knowing that, all of them are wrong except for C. Universal Time Coordinated, formerly Greenwich Mean Time, which is what I know it as. So we take C, Greenwich time. Now, if you're ever into ham radio or you're interested in ham radio, you always know that GMT is the time code that we use for amateur radio. So go to the next one here. Okay, well, we know this answer already. We answered in the first half, but to give it any information, we're looking for a signal that resends the signal. So the question says, what kind of amateur radio station automatically retransmits a signal from another station? Well, it would be a repeater station because it's repeating your signal farther out. So A, repeater station. What circuit has a variable frequency oscillator connected to a buffer driver and a power amplifier? Is it A, a crystal controlled AM transmitter, B, single sideband transmitter, C, a UFO controlled CW transmitter, or D, a digital radio transmitter? Well, it has an oscillator connected with a buffer driver and power amplifier. Well, there's no key. So a VFO controlled CW transmitter, maybe not. Digital radio? I don't think so. Single sideband transmitter could. But one that makes most sense is a crystal controlled, I would think. If I'm right. Because already you haven't introduced a signal to drive the signal. You have the buffer and the driver to drive the signal. You got the power amplifier. Crystal can be set for a signal and then help you tune it and help you listen to it. So that we have all the parts, I think it's a crystal controlled AM transmitter. No, they're looking for a CW transmitter. Interesting. Okay. When you read these questions, you're going to find like one sounds stupid. The other one sounds just as dumb. The next one makes more sense. And then the third one just makes absolute sense. Okay. A reliable means to prevent or indicate overmodulation must be employed if an amateur radio station is A, telephoning in use, B, telegraphics in use, C, DC power, and the analog connector analog or connector circuit to the final RF stage is in excess of 250 watts, or D, the person at the other end of the holder authorized to use the station. I know I have a saying that, if it sounds too technical, it could be the first answer. In this case, I'm going to go that route. So I'm going to go with C. That just sounds way too long and sounds too technical to be right. Oh, no, they're looking for that one. Radio telephone in use. So what is radio telephone? Basically voice. Okay, here we go. In addition to complying with the Radio Communication Act and regulations, Canada radio amateurs must also comply with the regulations of the blank. American Radio Relay League, Radio Amateurs of Canada, Inc., International Amateur Radio Union, or the International Telecommunication Union? Well, the American Amateur, the ARRL, nothing to do with here. I've never heard of the International Amateurs Radio Union. Never have I ever heard of the International Telecom Union. If I remember, it's B, Radio Amateurs of Canada, because they're one of the governing. They're like our governing body in a sense. No, they wanted the International Communication Union. Oh man, I'm doing bad on this one right now because we have answered total answers of 18. We only got 9 right. So that's like 50% right there. We're doing terrible today, good people. And I don't mind that, because doing terrible doesn't mean you're failing. It doesn't mean you're doing well. That's all. See, I've always been a person that's always scored low on tests. So getting this 80 is going to take me a very long time to get it. So I'm willing to practice again and again and again and again. I only do this online once every Sunday, just to put out some content, talk to you, the people that watch this channel. Thank you so much. I do appreciate it. But don't be afraid to chat. I'm always open to reading your comments and suggestions. So, feel free to leave a message or whatever. Even if I can't read it, I'll try to figure out what you said. Patch's exam question number 19. The fact that energy transfers from a primary second winding in a power transformer is not perfectly indicated by A, electrostatic shielding, B, large secondary current, C, high primary current voltage, or C, warm ironing laminations. Well, the lamination would show if it wasn't wrapped up properly. Electrostatic shielding, I don't think is the answer we're looking here for. A large secondary current? Somebody's telling me high primary current or large secondary current? Currents with an S. Current is the, I don't know. I'm going to say C. I'm going to say D. B. Large secondary currents. I have a feeling C, though, but I feel B might be the right answer. Either it'd be B or C. Let's just put it that way. No, D. Warm iron laminates. I'm thinking D, but when it's talking about current, I was thinking wrappings. Well, you would see the wrappings if it was shield, but I didn't think it'd be warm iron laminates. Okay. The resonance in a conduction exists when resonance is equal to resistance. Sorry, resistance is equal to reaction. The current contains no resistance. Inductive resistance is only opposite of the circuit. Inductive resistance and capacitive reactance are equal and opposite in sign. Resonance is the condition when resistance is equal to resistance. Resistance. Reactance. I'm not sure. I'm going to take a guess. D is correct. It's good to know. I'm going to take a break, guys. I'll be right back. I'm going to need to take care of something, so I'm just going to go might kill the video, or I'll just leave the video up, and I'll be right back. Let me put up a banner here. Okay. I'll leave the question up for you guys to look at. Sorry about that, everybody. I just had to go take care of something. So what I'm going to do is I'm going to throw this on here. If you guys want to help fund the channel, that's one way you guys can help fund if you're interested. Not required, just saying. Anyways, let's get back into the questions here as we go on. Which of the following is not correct? While operating radio in the amateur radio license, Government of Canada, radio amateur license by the government of the United States must identify the. So we got a couple questions, answers here. I don't know which ones are correct, but we're going to read them and we're going to discuss and we're going to figure this out. Let me go back to my comments page so I can see what you guys, if anyone's chatting to me. Which of the following is not correct? While operating a Canada A radio amateur license by the government of the United States must qualify his designation when operating phone, adding the call sign words mobile or portable when operating Morse code by adding a slash. Not sure about that one. Obtain a Canadian amateur certificate before operating in Canada. Makes sense. Identifying with the call sign assigned by the FCC. Well, that makes sense because the FCC is the governing body of the amateur radio spectrum for the United States. Adding his call sign, Canadian call sign of the Canadian call sign with a prefix for his geological location of station. He can go get himself a Canadian amateur radio license, or he can identify with the FCC. I know there's a form that when we go to the States, we have to fill out stating our call sign information. I have to permit this document even if I'm going to the States now all the time, especially if I have my radio with me. If I don't have my radio with me, but I plan on doing radio communication, I still have to fill out this form. So if I go to the States, I fill out the form. And I've got to have to do it at every border crossing now, from now on. So it's a pain, but that's what we have to do. I believe it is C. Nope, they have to obtain a Canadian amateur radio license before operating in Canada. See, I was told differently that we have permission to broadcast in the States and in Canada. But apparently they're saying he has to have a Canadian amateur certificate before operating in Canada. So I guess in the States, I had to fill out a form and get my FCC call sign to do any broadcasting in the States, I guess. Yeah. So right now we are failing by 1 score. Let's have a look. Well, actually failing big time, but we won't know how bad I failed until after it. Most common material used to make a resistor is carbon, lead, gold, or mica. I know carbon's used. Lead, maybe. Gold, or mira. I think gold and mira are out. Either it's carbon or it's lead. Now I know there's a carbon resistor and there's a lead. No, I think it's lead. Watch it be carbon. Watch it be carbon because I'm picking lead. It's going to be carbon. I just know it's going to be carbon. But if I pick carbon, then it would say lead. So it's one of those two. I'm like 80% sure. But it's saying lead right now because we use lead to tin and to build boards and everything else. We use solder. Solder contains lead. I'm going to say lead, but watch it be Carbon. Like watch this. Carbon. See? Told you. If I picked lead, it would have been. If I picked lead, it would have been carbon. If I picked carbon, it would have been lead. Always the case. Always. See, I don't think carbon would have been the answer. Honestly, I think there's certain like carbon resistors, because that's what's the resistor for carbon. Well, I should have known better. Anyways, how to modulate a 2-meter FM transceiver to produce packet radio transmission? Connect the terminal mode controller to the input of the transceiver carrier wave. Connect the keyboard to the transceiver microphone input. Connect a DTMF keypad to the transceiver of the microphone input. Connect the terminal mode connector to the transceiver microphone input. We can't hook up a keyboard to it. Keyboard needs to have a component to make the sound. So B is wrong. D. Okay, so on the most amateur radio operators devices, it has a phone keypad on it. That phone keypad can allow you to do auto patching, which is going into a phone line and making a phone call. There's also something called allows you to lock into different repeat, like if a repeater has something like Echolink or has some digital mode of IRLP, you would use that to call into the IRLP section of the modem and try to make a call out. Connect terminal mode controller to transceiver microphone input. I think it's the input of the microphone, because then that would produce the carrier wave. So we're going to go D. And D is correct. What happens to a signal that is overmodulated single sideband or double sideband phone transmitter? It becomes stronger with no effect. It occupies less bandwidth and poor high frequency response. It has a higher fidelity, improved signal to noise ratio. It becomes distorted and occupies more bandwidth. Well, we know the answer for that one. Occupies more bandwidth, because you're overmodulating your signal. So think of it like turning your radio up past 11. It'll just like, you'll get like that loud, like it's almost unbearable. It'll be something like this. I'm going to move this up here so you guys can get an idea. Hopefully that was almost unreadable, but that's basically what you're putting out. So it's D. What sound is heard from a public address system if the audio refraction of a nearby CW transmission occurs? An on and off humming or clicking, an audible but distorted screech, muffled, severely distorted speech, or a steady whistle? Well, we know when it affects speech, because CW is click, 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 click. It's a beep, a beep, 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 a beep, 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 beep. So I don't think a steady whistling would be the answer. Muffled or silly distorted speech, or audible, possibly distorted speech. That's if they are talking on the public address system. But what sound would you hear? I would think an on and off humming or clicking, because when you click on a key, you're actually touching a power lead, which makes that little click, 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 click. That's how it knows how to go for a longer beep or shorter beep. I'm going to say clicking, because you click when you do it. So let's go with on and off humming or clicking. That's correct. Next. Okay, this is very important. RF. RF is dangerous to the body, but which area is it deadliest to the most? So it says, which body organ is most likely to be damaged from heating effects of RF radiation? Will it be your heart, your eyes, your hand, or your liver? Path of less resistance would be through the eyes to enter your body. So I'm going to say eyes. I do remember saying about eyes being affected by RF. The answer is A, eyes. Oh, it's a path of less resistance. So an amateur radio station may communicate with anyone using international Morse code, only with other amateur radio stations, with stations involved in real or simulated emergencies, with non-amateur stations. What is the correct answer here? This can be tricky, because there are programs where amateur radio operators work with emergency response people to simulate the emergency response. So sometimes amateur radio operators will be involved in that. Anyone who uses international Morse code, well, that's kind of not what they're looking for. Non-amateur radio stations, ha 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 ha. Yeah, we're not used to. But if you don't have an amateur radio call sign, you shouldn't be on amateur radio. With any station involved in a real or simulated emergency, I'd say we're allowed to talk to them. We're not supposed to communicate with them. If there is an emergency, we can take the emergency information and pass it on. But usually it's B, only with other amateur radio stations. From what my knowledge, for what they're looking for, I believe that's the answer they're looking for. Yeah, that's the one they're looking for. In an HF station, the antenna tuner is commonly used to tune into a dummy load, to tune low-pass filters, with most antennas while operating below 14 hertz, with most antennas operating above 14 hertz. Now, the antenna tuner, from what I know, is to prevent less SWR and to give you a good signal frequency when you're transmitting on those bands. That's what I believe an antenna tuner is 90% used for. But I don't think it's used to tune into dummy loads. To tune a low-pass filter, well, a low-pass filter is already preset for the filters that it can accept. Most antennas, when operating below 14 megahertz, or most antennas operating above 14 megahertz. I would say probably it's above 14 megahertz. Let's see if that's the answer. Nope, below. That's right, because we start at 30 and work our way down. So yeah, because then what is 14 megahertz? I think that's like the 20 meter band. Then we have 7.43, which is 70 megahertz or 75 or 80. Yeah, so yeah, because you got to remember, I'm thinking frequency going up, not going down. My bad. Which component can amplify a small signal but must use high voltage? Okay. A vacuum tube, a transistor. Oh, a transistor. Okay. Electrolytic capacitor or a multi-cell battery. Small signal, but must use high voltage. If I remember correctly, I believe vacuum tubes is the one that we want here. Yeah, vacuum tube is requires high voltage to put out a small signal. What device might allow use of an antenna or a band that is not designated for? That would be an antenna tuner. That's something else an antenna tuner can do. Depending on the SWR, you can use anything to transmit. You can even transmit off a wire if you wanted to. But it matters on if your radio can tune in for that frequency. If it has high SWR, you can hit the antenna tuner and hope, pray to God that you get a good SWR. But if you don't, you're just going to have the power come back into you and fry your system and even hurt you. So keep that in mind. So 60 hertz. For this, I know it's not meters per second. I know it's not 60 meters per second. That has nothing to do with meters. Hertz involves cycles, wavelength. I believe, if I remember correctly, megahertz would be 6,000 cycles per second. This is 60 seconds per cycle, or 6 cycles per second. And this is common knowledge. If you look at TVs always start at 60, and that means the hertz, the signal wave is only 60 hertz. I mean, how fast can picture be processed? We now have monitors that can go up to 120. There are TVs that can go up to 240. When you go at 240, you're tripling. I think it's quadrupling. No, it's tripling the amount of quadrupling the frames amounts that can be processed. That's why if you ever watch sports and you get like that soap opera effect, that shininess, that is your TV trying to compensate and trying to draw more lines than what it can produce. A little bit of trivia for you. The character's impedance of a transmission line is determined by A, frequency at which the line operates, B, physical dimensions and relative position of the conductors, C, the length of the line, or D, the load placed on the line. So impedance would be how length of the line frequency of which the line operates. I don't think is what they're asking here. Physical dimensions and relatively position of the conductor. There's no mention of conductor on this line, so I'd say that probably is not the answer they're looking for. Total load placed on line or length of line. My mind's telling me to go length of line. I have a feeling it's definitely wrong. You know what? We're going to go length of line, though. I've always been told, go with the first answer that stands out to you. Don't double guess yourself. Because when you double guess yourself, you're going to get it wrong. But I have a feeling here I'm missing something here. And I've never seen, and this is something interesting. I've never seen this question. I never have. I think it's length of line. I was wrong. It's B. Physical dimensions and relative position of the conductors. What conductors? Impedance of a transmission line is determined by the blank. Sometimes these questions can be very confused, can be very what they're not looking for. You think, okay, well, that makes the most sense, length of line. But they're talking about physical dimensions, okay, and relative position of the conductors. What conductors are we talking about? What? Oh, I hate questions like that. Okay. If your third floor amateur radio station has a ground wire running 10 meters, 33 feet down to the ground rod, why might you get RF burn if you touch the front panel of your HF transceiver? Because the transceiver heating sensitive circuits is not working to start the cooling fan, because your ground rod's not making good contact with the moisture of the earth, because your ground wire has significantly resistance acting more like an antenna rather than an RF ground connector, because of a bad antenna connection, allowing the RF energy to take an easy path out to the transceiver through you. Well, your third floor amateur radio station has a ground running 10 meters, 33 feet down to a ground rod. Well, I'm going to have to say D. Because taking the path of less resistance. That 33 line down could be longer path. This is a shorter path, like they said, shorter paths of less resistance. Yeah, so it takes a path of less resistance. You will become less resistance. Your ground wire is acting like an antenna. Correct. Energy takes the path of less resistance because it's a bad antenna connection. If the resistance is not connected properly to your ground wire, so you would get the zap back because you're giving it. This question can be very argued. I am definitely going to write this one down. Because technically, the answer is correct, taking the path of less resistance. But why would I be answering that it becomes an antenna? Why is that? B dash. Okay, so I gotta get that looked at. I'm gonna send this off to my person that was helping me study for this exam, and we're gonna find out why is that not the correct answer. Why is it not the path of less resistance? Why would it not be that answer? Because it's saying the same thing. Well, we're still going through this. We're going to try to answer as many as we can, or until timer runs out. So, which statement is not correct? Now, safety code 6 is something new that they brought out, and it's all about RF interference and how much RF can we accept as a bot in our human bodies. Oh my God. Oh, sorry guys. I had something get caught in my throat. I just couldn't breathe. All right. There we go. Oh boy. Got whatever was stuck. Finally moved. Okay. Which statement is not correct? Safety Code 6 specifies lower exposure limits to the general public in uncontrolled areas than it does for people in controlled areas. Safety Code 6 uses different units of magnetic field strength and electronic field strength when standing limits. Antenna gain, distance, transmitter power, frequency are all factors which influence the electrical field. Oh my God. You're still going. How are you doing? I'm doing fine. Thanks for asking, Andy. Let me repeat C again. It's a lot to talk about. Antenna gain, distance, transmitter power, and frequencies are all factors influencing electronic field strength to a person's exposure to radio energy. Handheld transmitters are excluded from the Safety Code 6 requirement. See, Safety Code 6 wasn't out when I first studied for my exam. It came out this when I studied for my exam this time around. When I was studying in 94, this was not a question. There was something else called static wave energy, which kind of consisted of the same rules. I know A and B are correct. C is correct. I'm going to say D is incorrect. Because D is part of it. I remember seeing that in my exam notes. An SWR meter Measures the degrees of which the transmission and line intended by A, measuring the conducting temperature, B, inserting a diode in the transmission line, C, measuring radiation RF energy, or C, comparing forwarding reflecting voltages. So standing wave ratio, which is known as SWR. Now, if I remember correctly, I believe it's not measuring conductor's temperature, and I know you don't insert a diode into an antenna line. Measuring radiated RF energy sounds more correct than comparing forward and reflecting voltages. But SWR, if it's standing wavelength, can come back and fry you into your radio, because standing waves are a bad idea. So I'm not sure if it's the voltage or it's the RF. I'm going to say RF, because RF is bad. And standing wave ratio, I believe, works with RF, if I remember correctly. But I could be wrong, and it could be D. Let's find out. It is D, comparing forward and reflecting voltages. That's what they were looking for. Okay, that makes sense. And as you see, guys, as I'm going through this, I'm asking myself, is it one of the two? Because I know a lot. When it comes to theory, in one ear, out the other. But you give me a graphic and you show me how that works, it then sticks in my head. It's just who I am. It really drives me batty when we have exams like this, and you're just like going, well, which one is it? Is it A or is it, When an amateur radio station is transmitting, it must where must its control operator be? Anywhere in the same building as transmitter, at any station control point, a station entrance to control entry in the room, anywhere within 50 kilometers of location. Well, I was looking for a control point, or are they looking for the entrance to control? I'm going to say, I would say the amateur radio station transmitting, where must the controller operator be? In the room where the equipment is transmitting from. That's what I would think would be the correct answer. That is not here. We know it's not the same building. We know that's totally wrong. We know anywhere within 50 kilometers? No, that's not what they're looking for. At the station entrance to control entry in the room? I'm starting to think it's this one, at the station control point. That's what they're looking for. Yep, at the station control point. That's what they were looking for. It's the way they word things. Now, you notice, like, each B has like a little number beside it. That tells me what module it's coming from. So this is module 1 of the book. The book I used to study from was this one right here. Ham Study Basics. Let me go zoom in on the main one. Here. So if you're looking to get your Canadian license, this is the book you should look at. There are spelling mistakes. Yes, granted. Every book has a spelling mistake here or there. If you really want to nitpick, you can nitpick. But this also has an online component to it too. I prefer having a book kicking around so I can always reference it. The online edition, you have to pay for it, and it's updated yearly. But if I find something that I question about, I can easily look this up in the book and find out what it is. Because like with number B3-19007, I'm going to run that by one of my amateur radio operators that I know well. And we're going to pull it up in the system and we'll find out why is my answer wrong and why are they looking for that answer specifically? Because they're both the same thing. Because if a ground is wired badly, the antenna is going to be wired bad in the beginning of it. So answer me this. Why? You know, it's just the argument of it all. Let's get back into this. Okay, 37. So the figure in a receiver specific specifications, which indicates the sensitivity of the blank. What? Okay. Audio output in watts, bandwidth of the IF in kilohertz, number of RF amplifiers, or D, RF input signals needed to archive to given a signal plus noise to noise ratio? What are you talking about? The figure in a receiver specifications. I hate when they give us questions like this. There's no answer really to tell me what I'm looking for. Whatever. Answer the longest one and see what happens. T is correct. Weirdest question I've ever seen in my life. I'm gonna write that down because I've never seen that before. And the nice little thing about this is that every question that you see on this list, like right here, B, and this lettering here, I can call that up in the computer and I can find out more of what that means exactly. Okay. In a regulated power supply, the blank is in between the input and reflector. Is it a filter? Is it your output? Is it a transformer? Or is it a regulator? Well, we know it's not output. Input and reflector. It could be a filter or regulator. I don't think it's transformer. I think transformer is after rectifier. Let's put filter. So it tells me it's not the answer, but I don't know the answer to this one. I really don't. Don't remember this one at all. Transformer. It is a transformer. What do you know? Hot dang. Okay. Skywave is another name for an inverted wave, an ionospheric wave, a ground wave, or isotropic wave. Ionospheric wave, I think, is the one I'm looking for. Yep. What is one meaning of Q signal of QSY? Okay. QSY is not send slower. QRM and QRN. I've never seen a code for send faster. Use more power. Change frequency. QRM is that one. QSY is not send slowly. Send slowly, I think it's QS. Is QSY? Send more slowly? Okay, so this is definitely used more in Morse. I've never heard when you use more power. Don't know my Q codes this well. Send more slowly. I think it's QSB. I want to say use more power, but I have a feeling it's going to be send more slowly. But let's see what happens. Oh, B, change frequency. Okay. Practice exam ID number. Oh, I'm not going to get into that. Oh, yeah, okay. This is good. Okay. In a three-element directional antenna, Yagi basically, the blank is primary for the mechanical support purpose. Is it the director, the boom, the reflector, or the driven element? It's B, the boom. These pieces, the director, reflector, and driven element, are on top of the antenna. Here it looks like mechanical support. So to hold the antenna up would be the boom, I would think is what they're referring to. Yeah, they're referring to the boom. What is one effect of increasing the boom length and adding a direction to Yagi antenna? Wind load increases, gain increases, weight increases, SWR increases. Oh, if you're adding a length, wouldn't that be your gain would go up because you'd be higher up, so you get a better gain? But I don't think that's what they're looking for. Your weight does not decrease. We know that because you're adding more to it. So your weight would increase. Your SWR would increase because you're adding more line to the length of your antenna. So it could increase your SWR. I think here, I want to say SWR because the longer you make your antenna, the more then you have to readjust for your SW. I'm going to say SWR. Gain. So either gain or SWR. That makes sense. But just to question that, I'm going to run that by one of my directors. What is the main reason? What's the main reason the 160, 80, and 40 amateur bands tend to be useful only for short distance communication during daylight hour? Because of the aurora propagation, because of the magnetic flux, because of the D region of absorption, or lack of activity? Well, we know the answer for that. It's the D region of absorption. So when we're talking about these bands, we're talking about the ionospheric bands. So you have I believe it's D, E, F. And F I know splits up into two during daylight hours, and your D can absorb will absorb the most RF energy. allowing your bounce not to be as good. So it doesn't reflect. It absorbs 90% of the energy. Whatever is left doesn't go anywhere. It just becomes energy out there, open. In Morse code transmissions, broadband RF interference key clicks can be heard in distance, is produced by a poor sharpened waveform, shift in frequency when keying the transmitter, sparking on the key contacts, or sudden movement in the receiver loudspeaker. Well, poor shaping waveforms, shift in frequency while keying the transmitter, possible, but not the correct answer we're looking for here. Sudden movements in the receiver loudspeaker, that has nothing to do with making noise. It is actually sparking at the key contacts. So if your key is sparking, it's adding more noise to that key, to that stroke. So in turn, it's sparking at the key contacts. Oh, no, part of the shape and waveform. Yeah, if I was always sparking key, okay, maybe that's not the answer they were looking for. Because last time I ran into this question, it had almost the same question, and it was sparking at key contacts. Unless there's a different wording on that, unless it's number 8. So that might be a little different there. $45. In a parasitic, if a parasitic element slightly longer than a horizontal dipole antenna is phased with a parallel with dipole of 0.1 wavelength from it, what does the same height effect will this have on the antenna's radiation platform? A major lobe will develop on the horizontal plane from the parasitic element towards the dipole. A reflection pattern will not be affected. A major lobe will develop on the vertical plane away from the ground. Or D, a major lobe will develop horizontal plane parallel the two elements. Oh, I love antenna theory when it comes to this stuff. If I remember correctly, I believe the major lobe develops in the horizontal planes of the parallel of the two elements. No, it's A. So the major lobe will develop on the horizontal plane of the parasitic element towards the dipole. Okay, we'll have to look into that one. So that's some antenna theory for you. Antenna theory. I thought it was always on the major lobe would develop between the two planes. Close. In a single sideband transmitter, the output of the linear amplifier is connected to the what? It's like the arm is connected to the thigh bone, that type of stuff. Same idea for this one. Single sideband transmitter, so a SSB. The output linear amplifier. So the linear amplifier would be connected to the what? The filter, the variable frequency oscillator, the antenna, or speech amplifier. Linear amplifiers makes me feel it would be connected to the antenna because there's no other one next to it. It's connected between the. So I'm going to say antenna. C, final answer. C is correct. Because any of the other questions, if it was an ending, It's a in between the two. When it just gives you one ending, that means it's just that's what they're looking for. A semiconductor described as a general purpose audio NPN device. This would be a trioid, a silicon dioid, a bipolar transistor, or D, an audio detector. A semiconductor described as a general purpose audio NPN device would be audio. An audio detector? I am going to go with audio detector. I forget this one. I have a feeling it's not, but we'll see what happens. Bipolar transistor. Okay, bipolar transistor. These are ones I'm not good at, especially when it comes to electrical theory. Terrible at it, as you guys already know. Like I said, I gotta go back and study this stuff again, and I really need to sit down and hunker down on this stuff again. Which two types of radiation from the sun influences propagation? A sun-bendable and audio frequency emission polar region and transmission, electromagnetic and particle emissions. I don't know. So which are the which two types of radiation from the sun influence propagation? Is it the sunnable and audio frequency emission? Is it the polar region in equator emissions, electromagnetic and particle emissions, or infrared and gamma rays? I can't remember. I know the sun sends out infrared, but I'm not sure if it sends out gamma. It might. It does have the power to do that. It wouldn't be anything about audio frequency emissions. Wouldn't be polar. Polar would be something else totally different. Is putting out energy could be electromagnetic and particle emissions. But I know infrared, heat, that type of stuff has, I'm not sure. I'm going to go with the gamma ray just for fun. I have a feeling it is C, but I'm going to try D. No, it is C. I was right. Should have gone with C. How many times must power output of a transmitter increase to raise the S meter reading on a nearby receiver from an S8 to an S9? Oh, I love this one. Transmitter increased to raise the S meter reading by 1. 2 times, 4 times, 3 times, or 5 times. I think it's 4 times if I remember correctly. Yeah, 4 times. Inductance in AC must be opposite of both resistance of the winding wire and resistance due to individual effect. The term, which includes resistance and reactance, is inductance, impedance, resistance, capacitance. I think it's capacitance. No, impedance. That's what I was looking for. Which component has a positive and negative side? A resistor, a battery, battery. If you're a net controller of a daily RHF net, what should you do if the frequency which you normally meet is used just before the net begins? Increase your power output so the net participants are able to hear you over the existing activity. Reduce your power and start net as usual. Cancel your net for the day or ask the occupants to resequence the frequency for the scheduled operation. If they are not agreeable, conduct your net on a frequency 3 to 5 kilohertz away from the regular net frequency. D. Because you ask them nicely to move. They don't want to move. Fine. Then you got to do is you got to go 3 to 5 hertz away, kilohertz away. Me, I would just yay, and just tune up on them. I know you're not supposed to do that, but I hear it happen a couple of times in the day. You'll hear a net start up, and somebody will go, someone say, "Can you listen to this frequency? We got a net going on here," and usually they don't respond. So someone will, then definitely you'll just hear someone all of a sudden key up their tuner. I've heard it. And then they usually get the message and they usually leave, and then they relinquish the frequency for the net. But I have seen it happen before. In a CW transmitter, the blank is in between the driver buffer stage and the antenna, the master oscillator, a telegraph key, power supply, or power amplifier. Okay. So we know it's not the telegraph key because the telegraph key is before the driver buffer. I know that much. Master oscillator could be the answer, but I don't think so. I think it's the power amplifier that goes there to amplify the signal so it can get out to the antenna. So I'm going to say power amplifier. Yeah, D is correct answer. Oh, fun. Why is a 5/8 wavelength vertical antenna better than a quarter wave length vertical antenna for UHF and VHF operation? A 5/8 wave antenna has less loss and less Corian loss. A 5/8 antenna is easier to install in a car. The 5/8 length antenna has more gain, or the 5/8 length antenna can handle more power. If I remember correctly, it's more gain. To make it more easier to install in a car. Yeah. Get her in a car, call William a tar. But if you want to put an antenna on, just remember 5/8 has more gain. But it's just like I look at 5/8 on a car is easier to install in a car. Usually with mag mounts, it's the easiest thing to install in a car. But whenever I hear a car become near the Buffalo area, there's this guy that calls himself William a tar. And he says it like that. He goes, heard in a car, call William a tar. Anytime I think of car, William a tar comes into mind. Yes, I watch too much U.S. television. Sad as it is, it's that 90% of the good television comes from the U.S. But anyways, we're getting off topic. So anyways, if a single stream report is 20 dB over S9, what should you report transmission powered? What should you report if your transmission power is reduced from 15 to 150 watts? Oh boy. 150 watts to 50 watts. Oh, hi, DX398. Thanks for the LOL. I appreciate that. If signal strength report is 20 dB over S9, drop it down 100 watts. No, you dropped it at 1,000 watts. Would it be an S9 or would it be an S9 plus 5? I think it would be an S9. No, but plus 10. Really? That much drop? Huh. A low pass filter substitutes for high frequency transmission would A, pass audio frequency below 3 hertz, 3 kilohertz, pass audio frequency above 3 hertz, attitude frequency below 30 hertz, or attitude frequencies above 30 hertz. Well, low pass filters to block higher frequencies would block higher frequencies. So it would attune frequencies above 30 megahertz or below 30. I think it's below 30 megahertz if I remember correctly. No, it's above. Okay, my mistake. I know this content is not the most exciting information. Hopefully you guys are enjoying it. If you do enjoy this, you can always give it a thumbs up or, just, leave a comment down below or even just talk in chat, And Andy, I know you're out in the UK. Are you HF enabled? Do you do HF or no? Just out of curiosity, I thought I would ask you. And DX398, are you also do HF? And if so, what's your favorite HF band? If not, what bands do you like playing in? Do you like playing in digital? UHF, VHF, 2 meter? Just a curiosity. Thought I'd ask both of you guys and know a little bit more about you guys. Anyways, we got 3 people watching. Hey, to the third person. You can also join in chat. But I'd like to know, what's your favorite band? What do you guys like playing in? You guys can comment, leave a message about that. I'd like to know. Anyways, what is coax cable? 2 wires twisted around each other in a spiral. 2 wires side by side held apart by insulation rods. Center wire inside an insulated material, which is covered by a metal sleeve or shield, or 2 wires side by side in a plastic ribbon. Well, it's actually C. Just like coax cable, television cable. Same idea. Center wire inside it's almost, I don't believe it's wax. I think it's nylon. And then you have the metal wrapped around the nylon. They have like a metal sleeve on the nylon. If I remember correctly, that's what the inside core is. And usually the inside core is either is a type of copper, if I remember correctly. Oh boy, here we go. A lamp has a resistance of 30 ohms and a 6-volt battery is connected. The current volt will be 0.5 amperes, 0.2 amperes, 2 amperes, or 0.0005 amperes. Toronto HF enable, looking to buy my first transceiver. Oh, really? Congratulations. Yeah, I'm out in the Kitchener-Waterloo area. Used to live in the Toronto area. But my actual QTH used to be Mississauga. Used to be on the border of Mississauga just before you cross over in Etobicoke, about 20-minute drive away. So that's where I give you an idea of where I've lived. I lived right basically on QEW and Cawthra Road was my main intersection. Give you an idea of the area I was in. Like I said, 30 minutes drive downtown. Believe it or not, I didn't drive that often. I always took the bus because it was cheaper for me to take the bus to get downtown Toronto. I know that sounds weird, but when you're downtown Toronto, parking costs so much. I'd rather save that little bit of extra money that I could save, hop the bus. Because believe it or not, the bus was just about as fast as me driving down to the stupid station. So, say wear and tear. That's what I did. Oh, cool. Yeah, that's awesome, man. Yeah, we're still in the red zone. We haven't gotten to the gray yet, but I have a feeling we're going to be locked down very, very soon. Out here, I know that Toronto, Mississauga, that area is all locked down right now. I can't believe still that was it? I want to say Halton region is still in just went in red zone, but they're doing well. I would figure they would be the first ones because I thought they would be locked up right beside Mississauga, but no, Oakville, Burlington, Milton, they're still in the they just entered red zone, but just interesting stuff. Anyways, let's get back to the question here. If I remember correctly, 6 volts, 30 ohms would be 2 amplimeters, I think. Point 2. Okay, 0.2. In an amateur digital radio system, the transceiver is connected to the blank. Scanner, input, output, computer, or modem. I believe it's modem. Because modem would be connected to computer. What age must you be to hold an amateur radio license certificate for basic? Back when I was studying for this, it used to be 16, unless you had special permissions. Now it's any age. There is no age limit to get your amateur radio license. So you could be 5 years old and get an amateur radio license, which I'd like to see a 5-year-old get an amateur radio license. That would be kind of cool. And it'd be like one of those events that it'd be interesting. Just saying. We'd have to find a Sheldon, I guess. Which of the following statements is not correct? A disabled candidate must pass a normal amateur radio exam before being granted any qualification. Exemptions for disabled candidates may be given orally, tailored to the Canadian ability to complete the exam. An accredited examiner may recover the cost of administering the exam. A disabled candidate can take Morse code sending test, may be allowed to recite the examination test in Morse code sounds. Ooh, I want to say the accredited examiner may recover costs, which doesn't sound correct. But that disabled one sounds not correct either. I'm going to say C. Let's see what happens. But I have a feeling I might be wrong on this one. I can't remember which one it is. A. Disabled candidate must pass normal amateur radio certificate before granted any qualifications. Interesting. I didn't know that was a statement that would not be correct. I thought it could be right. A disabled candidate must pass a normal amateur radio certificate examination before being granted any qualifications. So a disabled candidate I know they can give it orally. I don't understand A. All right. My goof up. So we've answered 61. We only got 33 right. Yeah. Yeah. Thank you, DX. Yeah. So I still have my license. It's just I don't have the HF privileges. That's why I'm doing this test again. But thanks for sticking around. I do appreciate it. When transmission radio signals reaches a station by 1 hop, 2 hops, skip half, small changes in the atmosphere can cause a consistent fading or receiving signal, variation in signal strength, a change in the ground wave signal, or constantly strong signals. Variations in the signals. Fading or receiving signal could affect that. Variations in signal strength, definitely, I would think that. I'm going to say variation in signal strength. In the event of interference to a neighbor's television, according to the, I hate this one, the EMCAB-2, will determine a radio amateur's transmission and the cause of the problems if field strength A, at the transmitting location between the radio amateur's maximum allowance transferable power, B, on neighbor's premises above the Innovation Science Technology Government of Canada, specifically immune criteria, near the TV, below the Innovation Science criteria, at the transmitter due to the location on radio amateur's maximum power. Okay. So it's my radio that's causing the problem, I think is what they're saying. At the neighbor's preference. Okay, so it's the neighbors that's causing the issue. Okay, I misunderstood what they were looking for. If electromagnetic wave leaves an antenna in a vertical polarized, its arrival to receiving antenna by ground wave, polarized at the right angles of the origin, horizontally polarized, vertically polarized, or polarized on any plane. Well, if it comes out vertically, then it's horizontally polarized. No, vertically polarized. I thought it would be horizontally polarized. All right, vertically. I thought from vertical it goes polar. All right. Which of the following answers is not correct? Radio and bandwidth requirements. The following mode may be transmitted on these frequencies. The following mode may be transmitted on these frequencies. Okay. Frequency modulated FM on 29.6 megahertz. Fast scan television at 14.23. Slow scan television at 14.23. Or single sideband at 3.78 kilohertz. Okay, I know slow scan television is 14.230. Since fast scan is on the same channel, I'm going to say fast scan. Yep, fast scan television. because I know Fastcan is not qualifies for that signal. Fastcan television, I think, qualifies at a higher rate. I can't remember the actual signal strength now, but I know SSTV goes at 14.230. Why do I know this? Because I do some SSTV decoding. You can do decoding, you just can't transmit out if you don't have the frequency for it, and anyone can listen to it, even if you don't have an amateur radio license. What you do is you go online, you download a SSTV decoder. Then you just use like an SW, go to like web SWR, and you can listen to SSTV signals going in and out, and you can decode them. I do it with my phone and with my dongle, when my computer is on an SDR channel, listen to 14230, and I'll just decode it. In a single sideband and CW receiver, the blank is connected to the output of the audio frequency amplifier. I think it's a beat frequency oscillator, but it could be headphones. Yeah, speaker or headphones. Yeah, I know one of the two. No, it wasn't a mixer. I just couldn't remember if it was beat or if it was a that one. Amateur station may be used to communicate with any station which identifies for special contesting. A station operates under similar authorization. Armed Forces station during special contest and training exercises, or any station transmitting in the amateur bands. I think any station that broadcasts in an amateur band, you're allowed to talk to. Any station outside the amateur band, you're dead meat. Huh. Interesting. I'm going to look up that answer a little bit because I'm a little concerned about that. When two 500 ohms and a 1 watt resistor are connected in parallel, it can dissipate the maximum load power of what? 4 watts, 1 watts, half a watt, or 2 watts? Half a watt. Oh, 2 watts? Really? Oh. Okay. I figured half a watt because you're taking out 2 parallels. I didn't know it doubles the amount of watt resistance. Okay, kilo ohm is 0.1 ohms, 1,000 ohms, 10 ohms, or 0.001 ohms. Kilo ohm. I think it's B if I remember correctly. Yeah. That's obvious. What's the most part of your body that can be affected by? It's going to be your heart. Australia, Japan, and Southeast Asia are under which UTI region? We're under region 2. Region 3 is Europe. Region 1 is the US. I'm going to say region 4. Oh, region 3. Okay. And this one, I believe, the privilege is allowed by your qualifications only. But I'm not 100% sure on that one. Any privileges allowed by the additional qualifications? If you let another amateur with additional qualifications than yours control your station, what operating privileges are you allowed? Any privileges allowed by the additional qualification or only privileges allowed by your qualifications? If I remember correctly, it's your qualifications that matter because you're a station. But if an amateur has a higher qualification, they can use their qualification. But because your station, that's not allowed. If I remember correctly, I believe it's C. Yes. Next. Call sign of amateur. The call sign at amateur radio station must be sent every 15 minutes at the beginning and at the end of each exchange of communication, and at least every 30 minutes while in communication, every minute or once after initial contact. So this is an interesting question because the US, they have to do it every 15 minutes. According to their rules, at the beginning of their transmission, at the end of the transmission. Got it. So at the beginning and end of their transmission, they're supposed to give up their call sign. And they're supposed to give it every 15 minutes. In Canada, it's at least every 30 minutes. So the answer is B. That's why if you ever talk to an American station, you're Canadian, you'll hear them make more times they'll announce their call sign. By rule of thumb, I usually get my call out about every 15 minutes. By thumb. But I know it can be longer. But it's not required. Just something to keep in mind. Now, I know we're over the time allowance would be 2 hours. But the reason I am going through these with you with words, we're just going to go and finish this off. We got 25 more questions, not that much. And because I'm answering why I'm saying the answer is, so if I get the answer wrong, then I just write it down, draw it down, and go back at it. The holder of an amateur radio operator certificate may design and build from scratch transmitting equipment to use in the amateur radio service, provided that the person has basics, advanced, Morse code with honors, or basic Morse code qualifications. Now, I do know this for sure, that there is no honors in Morse code. So we know that C is definitely wrong. Basic and Morse code qualifications? No. Has to have advanced qualifications is the answer. An advanced radio operator will learn how each board works. So take, for instance, this board right here. This board was designed by VA3ZOT, a friend of mine. He has his advanced license. He knows me, and he's seen some of the stuff I've designed in amateur radio. He goes, that you should have a advance if you're going to be building that stuff. I'm like, come on, who's going to know? And when it comes to theory, like schematics, like you give me a schematic, I look at it and go, okay, I know what I'm looking at. You give me a design, I can understand that. But if you give it to me in writing, just goes through. It's just like in one ear, out the other. It's annoying, but it's the way my brain works. But there's advanced qualifications. I should know that one. That's like I've done some antenna designs, which I've sent to my friends who both own. I got a couple of friends that own the advanced license, and when they look at my antenna designs, my builds, and everything else that I'm doing, they're like going, "How in the hell did you come up with that design? It's beautiful." And it's just like I said, I got the mind for design. I don't got the mind for the math. Is my math correct? And usually they will look over my design and they'll go, "You got it," or "You don't got it. Here's what you did wrong." And they will show it to me on paper, why it won't work. And it's like, oh, okay. So if I change this and this, that antenna should work, right? And then I'll get a yes or no. It's kind of funny that, I have this mind that can work with pictures, not with words. If you've ever met people with learning disability like myself, I am ADHD. I have a hyper deficit disorder. What does that basically mean? I'm hyper all the time, but I've learned to control my hyper feelings. But I will, if I get the wrong stuff in my body, I don't pay attention to my diet, especially with this COVID-19 mess that we're dealing with right now. It's just a mess, but I got some other stuff coming up soon, so you might want to stay tuned to the channel. If you haven't already, hit the subscribe button, hit the bell, make sure it says all, because I got some new stuff coming down the pipe that you guys might find interesting. Anyways, let's get back to the questions here. If you have a light bulb marked 40 watts, 60 watts, and 100 watts, which one will use electrical energy the fastest? They'll be the same, the 60 watt light bulb, the 100 watt light bulb, or the 40 watt light bulb. Well, it would be the 100 watt light bulb because it demands the most energy. I would believe would be the answer. Yeah. They would not all be the same because they all require different voltages of power. When talking to a station using a repeater, how do you find out if you could communicate using simplex instead? See if you can clearly receive the station on lower frequency band. See if you can clearly receive the station's repeater input frequency. See if the third station can clearly receive both of you. See if you can clearly receive a more distant repeater. Well, there's one way to find out. Switch your radio over to the band that the repeater is listening at, its input frequency. And if you can hear the person, then yeah, you can do simplex. So B is the answer. If an alternating current is applied to an anode or diode, what would you expect to see in a cathode? A steady direct current, pulsating alternative current, pulsating direct current, or no signal? Okay, if the current is applied to an anode of a diode, what would you expect to see at the cathode? A steady direct current? Pulsating alternative current. I believe it's pulsating alternative current or direct current. Well, don't believe the anode changes the current direction. I'm going to say pulsating direct current. But I have a feeling it may be alternate current. No, it's C. Okay, I was right. What does it mean by receiving overload? Too much current from the power supply, too much voltage from the power supply, interference caused by strong signals on the nearby transmitter, or interference caused by tuning the volume up too high. Well, turning the volume up too high is not right. Interference caused by strong signals from a nearby transmitter. Usually overload means you're giving too much power from a power supply. What would it be, current or would it be voltage? I'd say probably current. No. They're saying the interference caused by a strong signal from a nearby transmitter. That's weird. Okay. The cubic quad or quad antenna consists of 2 or more square loops of wire. The driven element has approximately overall length of 1/2 wavelength, 2 wavelength, 3/4 of a wavelength, or 1 wavelength. Okay, my mind just went blank on this one. I think it's 1 wavelength, if I remember correctly. What I'm going to do is I'm definitely going to write this one down. Three-quarters of a wavelength, I think, is the answer. No, it is 1 wavelength. I was right. I double guessed myself. I thought about it. I went, no, wait a minute. No, that would be 3/4 because I was thinking you cut to drop the 2 lines down. I was thinking 3, 4. No, I was correct. 1 wavelength. Freaking, I'm dumb. Okay, the release a signal would be gain, I would think, not amplitude. I think gain is what we're looking for here. Yeah, gain. Because in audio, see, the problem is I'm thinking audio waves. So a lot of this I know translates over from audio, but I was trained in audio frequency. So like 4 dB, minus 4 dB, minus 0.01 dB. Those things make sense to me, but but I also understand what gain means, to gain more power. So I figure it's the same thing. It would be controlled by gain. An order of priority of the stress message comes before a government priority message, an emergency message, a safety message, or no other messages. An emergency message? Well, distress is emergency. Wouldn't it be? No other messages? I'm not sure what they're asking here for. I want to say safety. I want to say safety. Well, they're in distress. They are in an emergency. Yeah, emergency message. That's what they were looking for. Okay. Why should you wear a hard hat if you're working on the ground? Someone's working on your tenant tower. This is like the most dumbest question I've ever read. It's like, to protect your head from objects falling. So here's the answers they give you. They're kind of funny. To keep RF energy away from your head during an antenna testing. So somebody passing by will know that your work is being done on the lowering on the tower and will stay away. So you won't get hurt if the tower should accidentally fall. If the tower's going to fall, you're going to be dead. Sorry. Your hard hat is not going to protect you from a tower falling on your head. I mean, oh my God, this question is so dumb. To protect your head from something dropped from the tower. Hello, that's what you're protecting your head from. You're not protecting your head from a tower falling on top of your head. Oh, brother. So D, protect your head from something dropping from the tower. The amateur radio service is defined in the Radio Communication Act, the Radio Communication Regulations, the standard operation of radio stations in the amateur radio service, or the FCC Part 97 rule. Well, the FCC has nothing to do with Canadian rules, so that's out. Standard for operation radio, I don't believe so. If I remember correctly, the radio service, the amateur radio service, is a derivative of the Radio Communication Act. If I remember correctly. Nope, they were looking for the Radio Communication Regulation. So we have two of them. The Radio Communication Regulation forms the Radio Communication Act. To decipher the two, it's always fun. Either it's Communication Act or it's Communication Regulation. This one is the only one that requires Radio Communication Regulations. The rest of them are the Radio Communication Act, actually. Let me go into the trusty book and I'll read you a paragraph here. Okay. So that was, which one is that one? That one's number 4. Yeah, Radio Communication Regulation. So for these ones, the authority to make regulation governing radio communications is derived from the Radio Communication Act. That is question number B001-1-1. -1-2 says authorized to make the standards for operation of the radio station in the amateur radio service is derived from the Radio Communication Regulations, the Radio Communication Act, the standards for radio operations in amateur radio station, or the ITU radio regulations. Is actually the Radio Communication Act. Again, number 3 says the department that is responsible for the administration of Radio Communication Act is Transportation Canada, Industry Canada, Communications Canada, or National Defense. Well, that's Industry Canada. And then 4, which is the one we just got, is saying it's the Radio Communication Regulations. So that one I keep on forgetting is Radio Communication. So I got to watch out for that one. But it's in the book. Everything else is following the act. This is the only one where the regulation one doesn't fall into play. Next. When measuring the current drawn by a receiver from the power supply, the current meter should be placed in parallel both with the receiving power supply leads, in series with one of the receiver power leads, in parallel with one of the receiver power leads, or in series with both the receiver power leads. Usually positive and negative to make sure you're getting the right amount of lead power, I would think, would be where you want to place them. I think it's parallel is what we're looking for. Nope, in series B. One of the power leads is what they were looking for. Yeah, that's what I thought. Because the series should be placed in series with one of the power leads. What is the standard international phonetic for the letter A? Is it alpha, Able, America, or Atom? I thought it was always alpha. I don't know. I don't ever heard it being used for America, Able, and I don't think I've ever heard Atom being used. So I'm going to say alpha. The alpha. B is beta. C is Charlie. Speed of radio waves is the same as the speed of light. Varies in direction with frequency. It's infinity into space. Always less than half the speed of light. I think it's half the speed of light, if I remember correctly. I think it's half the speed of light. A, speed of light. Okay. I thought it was half, but okay. Sporadic E. Oh, I love sporadic E. How much I love sporadic E. What is sporadic E conditions? Partial isotropic ducting of the E region height, patches of dense ionization on the E region height, variations of E region height caused by sunspot variations, a brief decrease in UHF signal caused by sunspot variation. Now, sporadic E is partial tropospheric ducting by the E region. No, they're saying it's patches of dense ionization in the E region height. That doesn't make sense. I thought the E region becomes solid in the area, causing isotropic duction. Yeah. Gonna have to study that again. So we got 47 out of 87. That's not good. That's about 50%. But I will say it this time, I've run into some questions I've never seen before. So this is good because this is going to give me more of an idea of what I can expect. Now I could rewrite the test again. I'll probably score 80, but I want to make sure that every time I do this, I'm getting it right. So next couple of tests I might just do offline, and I will give you guys an update what goes on. Like I said, that information I'll probably put up on my Twitter account. So if you follow me on Twitter, just look up a Canadian Maker PR. I can't put project in as a full word, unfortunately. And you guys can follow me on there too. Just an idea. Or just search up VA3FUC. You should come up in their Twitter. So, if you guys want to join me in Twitter, go to Twitter right now. Fill out the paperwork, and I'll be more than happy enough to talk with you. So, what should keep a station from retransmitting music or signal from a non-amateur station? Turn down the volume of the background audio to adjust your transceiver noise blanker. Turn up the volume of your transmitter. Speak closer to the microphone and increase your signal strength. Well, if you can turn down your background audio, I'd say turn down the background audio. Would be my idea. But they're probably looking for speak closer to the microphone. Nope. They want a background audio turned down. Okay, cool. What's the cause for splatter interference? Keying a transmitter too fast, transmitting antenna at the wrong length, overmodulating the transmitter, signal from a transmitter outputting circuits being sent back into the input circuit. So it's overmodulating a transmission. What's the maximum usable frequency mean? The lowest frequency of the signal that will be reached is an intended destination. Lowest frequency signal to the most absorbed on the ionosphere. The highest frequency signal is the most absorbed on the ionosphere, or the highest frequency that is reached with the reach with the intended destination. The high frequency signal that would be reached is to the intended destination. That's what we're mostly doing. C, 91. The reason for using a properly adjusted speech processor with a single sideband phone transmitter improves voice frequency fidelity. Reason you use a properly adjusted speech processor with single sideband phone transmission to improve the voice frequency, to reduce average transmission power requirements, to reduce unwanted noise pickup from the microphone, improve signal intelligibility at the receiver. Well, improve signal intelligibility at receiver, I would think. Yep. 2. What is a good way to make contact on a repeater? Say the operator name and then your call sign 3 times. Say your call sign of the station you want to come in contact with, then your call sign. Say your call sign and station you want to contact 3 times, or say breaker breaker. Well, we know breaker is not the code. That's CB talk. So that's not us. Say the operator's name and then your call sign 3 times. That's been done before. Say your call sign of the station you want to contact, then your call sign. Say the call sign of the station you want to contact 3 times. It's actually B. You say the call station. So say if I want to contact VA3 PGT, I would queue up my thing and go VA3 PGT, VA3 FUC. And then I will wait for him to reply back. Whenever a change of address is made within the same province, there is no need to notify. I'm not going to repeat the whole information because it's just a lot of talk, a lot of words to say. Station shall not operate until a change of address is forwarded to. The Innovation Science Technology must be advised of any changes in postal address. D, the Innovation Science team must be notified within 14 days of operation of a new address. I don't think there's a date. I think you have to send it right away. So the Innovation Science Technology Development Canada must be advised of any change in their postal address. As I remember correctly, it's C. Yeah. 94. Okay. You cut a halfway dipole for 3.75 megahertz. What would be the appropriate length? Oh, crap. I'm not sure. Is it 45 meters? 75 meters? 32 meters or 38 meters? I think it's 45. Nope, 38. Next. In a field transceiver, the blank is the terminal where the carrier leaves the channel. The drain. I think it's drain. On an HF band, where is the scattered propagation most likely invoked? At night, when F1 and F2 regions are combined, when weak and distorted signals near or above maximum usability for normal propagation can be heard over unusual paths, or D, when sunspot cycles are at a minimum D region atmospheric height. I believe it's when F1 and F2 regions are combined. I think that's the answer they're looking for. Nope. When weak and distorted signals above the maximum usability frequency for normal propagation can be heard over unusual paths. That makes sense. 97. Amateur radio operators must not cause interference with other radio service operating which of the following bands? (14 to 1402), 430 to 450, 07 to 01, or 144 to 148 megahertz. I think this is what they're looking for. Nope, they're looking for 430 by 450. In a frequency modulant receiver, the output of the local oscillator is fed to A, radio frequency amplifier, limiter, antenna, or mixer. Don't think it's radio's frequency amplifier, but something saying frequency amplifier sounds about right. In a frequency modulated receiver, so it's receiving the signal, could be fed into the mixer to go into the microphone. I think it's a mixer. Yep, mixer. 99. So a person found guilty of transmitting false or fraudulent blah 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 blah. Okay, yeah. So you send out an SOS as a joke. Well, guess what? You get fined. And I'm going to say also there can be a prison sentence. Your fine will not exceed over 5,000, or prison term for 1 year, or both. That's what I'm thinking is what we're looking for here. Because you can fine and go to prison. So we're going to go with that one. Submit. Yep. Next. Question 100. We're at the end, everybody. So after this question, I'm going to get a report to see how bad I did. I know I did bad. This one I was hit with a couple questions I've never seen before in my life. And some of them I answered stupidly. But there are a couple here that I'm going to draw questions to, and I'm going to have a look into and study. And so I understand what did I not understand? Why is it that? And I'm going to be asking questions. So that when I talk to my person that helped me learn this the first time, I can ask them, why was this wrong? Why does this question not make sense? And hopefully he or she will be able to help me out. Or I may be directed to talk to somebody else that can answer that question for me and help me understand why wouldn't it be? And if I am correct, or it might be like, you are correct, but the reason they're looking for this is because they want to know what first goes on, or why does this, and see if I can understand it a little bit more clearly. That's why I write down these questions, because even my examiner, or whoever's helping me out with this, can point me in the right direction. So anyways, if a mobile transceiver works in your car, but not in your home, what should you check first? The speaker, the SWR meter, the microphone, or the power supply? The power supply. Submit. Yep. Finish exam. So we got 57, which is a fail, but I now know where I'm weak in. So I kind of screwed up on my regulations and policies. So I have to work on that one. 38. 5. So if you look at number 5, basic electronic in theory, I flunked that one, 38. And my antenna feed line, I flunked that one too. I got 23. Interference and suspicion, 40. But I did really good this time in operating procedures and station assembly and practice. And circuit components, I'm getting better at my circuit components. So that's good. I'm happy with those numbers right there. It's right here is where I really hurt. I had 13 questions and 13 questions in these two sections for basic electronics and feed line and antenna systems. So Those two I'd have to work on. But I have a basis of questions that I have questions about that make a lot more sense. And I wasn't sure what they were looking for in those questions. But I have the ones that I really want to concentrate on, and we'll go from there. So, with that being said, I want to thank you all for watching. Like I said, hit the subscribe button, hit the bell for notifications. So if you want to watch this again and watch me go through it, remember you can always talk to me in the chat. Chat's open. I love to hear from you guys. Love to hear what you're thinking. Love to see what you guys say. And with that being said, I want to thank you all once again for watching. And until next time, 73 and have fun out there, everybody. Thanks for watching. Bye now.